So good morning students. In today's class we are going to learn the linear filtering methods, overlap add method and overlap save method. In that we are going to solve problems based on overlap add method. So in the last class I have told you the procedure to do the overlap add method. So in today's class we'll be doing the problems. So the problem statement is given here. Perform x of n, convolute h of n where n ranges from 0 to 11 for the sequences x of n and h of n given below using overlap add fast convolution technique. So what is h of n given as 1 1 1 and x of n is 1 2 0 minus 3 4 2 minus 1 1 minus 2 3 2 1 and minus 3. So as we have seen, the procedure starts with the step 1. So what is the thing you need to calculate is you need to perform the linear convolution between x of n and h of n. Okay, so now the first step is you need to calculate the value of n, m and l. So first we'll start with the known values. So we know m is equal to the length of h of n given. So what is h of n given? 1 1 1. So there are 3 samples. So put m is equal to 3. And L you can calculate provided if n and m is given, whereas n is not specified in the problem, so we can take the other formula as 2 power of m. So 2 power of 3, it is 8. So if you are able to calculate L and m, we can calculate n using the formula L is equal to n plus m minus 1. So now substitute L is equal to 8 and m is equal to 3 and calculate what is n. So I am getting the n value as 6 here. And the second step states is that you need to frame the sequence h dash of n, x1 dash of n, x2 dash of n, x3 based on the given x of n. So first let us frame h dash of n. So h dash of n is obtained by taking the h of n values along with 0 padding, that is zeros I am going to add at the end so that the entire length becomes L. So L is nothing but the block length. So it is 8. Since the block length is 8, already we have 3 samples for h of n. I am adding 5 zeros at the end so that the entire length is 8. So which is named as h dash of n. So next you need to frame x1 dash of n. So x1 dash of n is obtained from x1 of n plus 0 padding. Okay. So x1 of n is nothing but from x of n we'll take the first 6 samples. So how this 6 is taken is since n is equal to 6, we'll take down the first 6 samples and then we'll add 2 zeros at the end so that the entire length becomes 8. So I have taken x1 dash of n as 1 2 0 minus 3 4 2 6 samples, then additionally 2 zeros at the end. So the next step is you need to find the circular convolution between x1 dash of n and h dash of n and name it as y1 of n. And we know the circular convolution technique. So using that I have solved it. I am getting the output y1 of n as 1 3 3 minus 1 1 3 6 2. Okay. So this is named as y1 of n. And this circular convolution procedure already you have studied in module 1. So you need to do the 8-point circular convolution between x1 dash of m and h dash of n minus m with circular convolution 8, so that you will be getting output as y1 of n. So the next step is again you need to do the circular convolution between h dash of n and x2 dash of n. So how to frame h2 dash of n is the next 6 samples from x of n you have to take, then you add zeros. So it will start with minus 1 1 minus 2 3 2 1. See, it is minus 1 1 minus 2 3 2 1 along with 2 zeros, 0 padding we have done so that the entire length becomes 8. So now let us do the circular convolution between x2 dash of n and h dash of n using the circular convolution method, and the output is named as y2 of n. So how much y2 of n we are getting is 8 values as minus 1 0 minus 2 2 3 6 3 and 1. So the next step is you have to find you need to add all the outputs such as y1 of n, y2 of n minus n plus y3 of n minus 2n plus go on. As it is specified in the problem statement that n ranges from 0 to 11. You can observe in the problem statement small n ranges from 0 to 11. So no need to do for y3 of n. You can stop with that. Why? Because if I am going to add y1 with y2 of n minus 2n, I will be getting almost 11 samples. So I am not bothering about doing x3 of n. Okay. So take y1 of n as such, and for y2 of n you need to shift it as I told in the procedure, as you have to shift y2 of n with respect to n is equal to 6, and it is shifted towards right hand side. So let us have a right hand side a shift of y2 of n. So later we will just add it. So we are going to add y1 of n plus y2 of n minus 6. So now we are getting y1 of n as 1, 3, 3, minus 1, 1, 5, 2, 2, minus 2, 2, 3, 6. And if you count the number of values, there will be 12 samples. So starting from 0 to 11. So hence we are able to calculate the linear convolution between y of x of n and h of n using overlap add method, and you can do the cross verification by doing the normal linear convolution between x of n and h of n. You can cross verify. There also you will be getting the same values. So this is about the overlap add method. So as per the procedure we have done it. Step 1 is calculating L, M and N. Step 2 is framing the sequence h dash of n, x1 dash of n, x2 dash of n, x3 and so on. Then you find out the circular convolution between x1 dash of n with h dash of n and name it as y1 of n. And in the next step, find a circular convolution between x2 dash of n with h dash of n and name it as y2 of n. So the next step is you have to add y1 of n plus y2 of n minus 2n plus y3 of n minus 2n. So this is added, you are getting the final output y of n is this. And as I told, you can cross verify this with your normal linear convolution procedure. Okay. Thanks for watching. Let us continue in the next video. Thank you.